I don't even have that. Oh, this I just got it today. Oh, right. So when we do the Excel now, we got time to revise it, right? So it's- that's a lot. I don't really mind it,
Okay.
Oh, shit. Is that for each thing? Wait, how would we do that?
I didn't agree to be on that. Finish it, we do that one for the mental block. Can you do one of those, huh?
Where's mine?
I should have bought the one we went to.
Did you just say that? Oh, wait, what was that question? So we just need to create graphs now?
No, there's a question.
So yeah, create graphs and answer questions. Oh, I left my one. Oh,
So we're just creating graph problem.
oh, did you guys get the last one? Did we do, what's the last one? Wait, what is this one? I don't have it.
Okay. So you guys remember this so far? Okay. So yesterday we talked about the different types of notating organic molecules. So this method here this method is called this method is called and then
Wait.
okay, so plastic isn't going to tell us jack, right? Because we don't know what that structure looks like. It could be a circle, it could be a, it could be a ring structure, circle. It could be linear. You could have things that are coming off of it. So the plastic isn't going to tell us it. So we rely heavily on the stuff. Some programs, what they'll do for the skeletal structure, they'll do skeletal structure, but the very ends, they'll put carbon. or they'll do like this. Right? So, like, for instance, the program that I used to write the questions, before it died on me, it does that, right? It does a mixture of both. So that tells us that, again, there's 5 carbons, right? Each one represents 4. Okay? And they just lazy, they put the carbon level in this one. Okay, so you'll see the skeletal structure drawn like this in some way. Okay, you guys with me so far? So, who's gonna name this one?
The name of the. I say
How would I name it?
classic skeletal?
No, I wanted the name of the chemical
Oh,
compound.
oh.
So, how would I go about naming it? Anybody want to take a guess? First thing that I'm gonna do is I'm gonna count the carbons. So how many carbons do I have?
5.
There's 1, there's 2, there's 3, there's 4, there's 5. 5 carbons. So it's 10. Okay, so why do I use 10? Okay, because there's only single bonds, oh, and 10. Right? So so if I have something like this. What is this guy going to be called? 15. Is there anything else I need to add?
What's the difference?
That's a good question. What is the difference? What is the difference between this one and this
Oh, there's an extra line.
one? There's an extra line. It's a double bond. So if you guys take a look here, there's a double bond, right? So we see that double bond.
Yeah, perfect.
So we count the carbons. We want to give that double bond the lowest number that we can give it, because we can count it this way. Count it this way, 1, 2, 3, 4, 5. Or we could have counted the other two, right? 1, 2, 3, 4, 5. So if I count it with the blue direction, it's on the 2, right? If I count it on the red direction, it's on the 3. So 2 is lower than 3, we want to give it the lowest number. So then we call this guy 2, 15. So that tells me that the double bond is at the second carbon. Okay? Questions? Concerns? $1 million?
For me? Yes.
Okay, so you guys ready for the next one?
Yes.
Okay, so let's
Wait, hold on.
okay. So this is called a cyclic domain. Okay, cyclic. So these are they're called ring structures or ring carbons or ring compounds or cyclic compounds. So the way that we would name this, we count the points again. So this guy has 1, 2, 3, 4, 5, 6. 6 carbons. What is the 6th carbon? X. So we start off with X. Okay. And then, is there any double bonds? No double bonds, so they're all single bonds. Hexane. And to signify that it's cyclical, meaning that it's totally connected, we put cyclo. Cyclo. So cyclohexane. So that tells me that it's a circle, right? It's a cycle. Okay. It's a ring structure. Okay. Questions? Concerns? Okay, let's add another layer.
I know.
Wait, don't erase it, don't.
Okay, so triple bonds, because if we look at the triple bond, let me just give you an example. Expand it. This is going to be linear, trigonal planar, trigonal pyramidal, bent, hot mess. Why is it linear? Was that? They all go in a straight line. And there's nothing attached, right?
Yeah.
So you don't have any other attachments to it, right? There's no lone pairs or anything like that, so we know it's going to be linear, right? So when we draw the triple bond has to be drawn linear. So to draw this, I would just draw a triple bond at the skeletal structure. Let's say I have this. And I erase this. Have this.
Oh, yeah.
Put it back up where you are. Okay, so this guy has how many carbons? 84. It has 4 carbons. 5 carbons. Okay, 5 carbons. Okay, where am I going to start counting from? Left, left, or the right? Okay, I'm going to start counting from the right. Why? Okay. Okay, so since it's closest to the triple bond, we're going to start counting from the side. So this guy's going to be called it has how many? How many carbons? It has 5 carbons. So since it has 5 carbons, it's going to be called time, right? Okay, so where is that triple bond located at?
Wait, one.
That's
You
right,
gotta find the level.
1. That's right. So we're going to put it at the 1, where that triple bond starts at. So if it's a double bond, we end with
There's 8.
okay, single bond.
Yeah.
Bond is all single bonds is A. Okay, double bond. Okay, and then triple bond. I can so kind, you know, I'm very so kind. Okay, questions? Concerns?
Yeah, I didn't understand that first
Five
where you're
carbons,
in the
so it's
last
10.
3 letters. So I was like, I understood the first 4 letters.
But now you get the last.
Yeah, I was like, why? Because it has 1 triple bond.
This day, it's like.
I was a couple days.
Yeah, so it's gonna be like, okay, so. Now, when we draw this structure, because this is linear initially, the way that the structure is gonna look like, it's gonna be a little bit different. So we have this going on, and it's gonna be straight. Then you're gonna have kinks. So that's 1, 2. 1, 2. This is your third one. 4 and 5. Okay, so triple bond is going to lead you to something that's going to be attached straight. Okay, where the others are going to have kinks. Can you guys see that? Don't see that? So- Because you want to show it as close to the way it really is, right? These guys, if they were right next to each other, these hydrogens would kind of interfere with each other, right? But if they're kinked, they're up here, the other one's down here, they don't interfere as much. Okay, so you draw them kinked because they want to be as far away as possible. You guys remember that? Yes, well, you want to try to get this the lowest number. So you don't start counting at the bond, you start counting to the side that's closest to it. Okay? So you can't count in the middle, you can't start counting. So you guys want to try another one?
Yeah.
A whole nother level.
Yes, please.
Okay. So. Everybody got this down?
So it's
What is that?
pent, it's pent because there's 5 carbons and the Y and E because of the triple bond.
That's right, because there's at least one triple bond. Right?
And then there's a 1 in front of it because it's at the first carbon.
Okay, it's a 1 because it's at the first card.
Okay.
Starts at the first card.
So it sounds like
What? Which one?
the last way.
It's the same thing that I did, except for, so this is just the expanded structure, this is the drawn structure.
If there's more than one triple bond, does it change?
Yes, we have to use die. We have to tell we're both right. Dying. Yes. Or exactly like I'm dying. I'll show you an example. But that's a good question. See, that was my buildup. See, you're already ahead of the game. Triple bond. Triple bond. So, can somebody do me a favor? You guys have your models out, your modeling kits? Okay. So what I'd like you guys to do is, I would like you guys to make me this structure.
Big what? The little ones?
Make the pin time, the one pin time. And you should be able to use the 5, you want to use the 4 carbons, all 4 carbons. Yeah, that's 4 carbons. Four holes.
And the hydrogen.
Yeah. So they need
Open up the box.
So how many they have right now? Oh, nothing yet.
Normally have
Do
4.
you guys have green ones?
4 bins electrons.
Yeah, and if you do, count how many you have.
Have any green ones?
No, okay.
No, you're gonna be using,
There should only be 8.
you're only
Yeah,
gonna be
we
using
have-
white books.
Okay, but waste because we have like a lot.
You have them?
Yeah, we used them yesterday.
You stole their.
We
Yeah.
did, we didn't have enough for everyone in our
Oh,
group.
okay.
That's why. I will, because you said, oh, tomorrow. I want to go home already.
And he
Yeah, you did.
No, he said he didn't want to
Now, if you're doing a double
No,
bond
he's not
or
yet.
triple bond,
No, but you're not thinking. He's like, oh, just tomorrow.
and you want to go 4 holes.
We get everything.
No, it's only triple bond.
Wait, is there any hydrogen that have more than one?
But for like just
Single bond? Probably no one says better. Is it N?
Yeah, and then double bond is P and E. Triple is Y and E.
and then 2 carbons.
Oh, not bad.
Just the long.
They're triple bonds, right? Wasn't it, you just said it yesterday? He said that before they want to make this like that, really small.
Yeah, these are just single bonds.
Awesome.
Yes.
What's yours?
Oh, you need to have. No, about
Sorry. You guys only want one. Cool, triple bond. Oh, triple bond.
Well, I'm gonna get them for Isaac's. That's the thing. I have party to do painting. And I have like a little station for the little kids, and I asked her, I was like, can I do it?
Only one of
I want to paint too, like a little high canvas. Yeah. I'm gonna get her like the big ones, smaller with paintbrushes, and then I go like pick up paint. I'm gonna get the washable ones.
Yeah.
That big one. You can't go wrong. You can. So we need the ones with 5 to 4 of it. I feel like. Okay, ¿qué te ayuda?
I just like. Sorry.
Aren't they supposed to be straight?
What are we doing?
Like, what's the new bit? Huh?
I love how you like shit. No, to class whatever, like back when you was I have not seen the proper movie going like 70.
So you have to bend.
Has someone like near my bed or they can go?
That's the tax rate though that you're
Thinking like, now we should let them off. Imagine there's like a cover behind you.
Okay,
Like,
you guys got it? That's it. That's it.
That's when I didn't know my text was
no, they said that
Okay.
cup can fall.
See, I don't know.
So, everybody got the nice little structure, looks like a little doggy, right?
No.
Okay. Doesn't look like a little doggy? Don't have the triple bond at the top, the end, so you see this part is linear, right? You guys clearly see that's linear, right? That front part is linear, exactly like this, right? And then the other part is kinky. See the kink? Okay, you guys see it?
Yeah, big ass roots. I wonder what he's like.
It looks like a little dog, right?
It does.
With his big tail, big bushy tail.
Wait, what?
It was
I
also
don't know. I thought the first.
That isn't a triple bond, that's a double bond.
Well, you took it from me.
Cause you were fucking throwing shit
Beautiful,
around.
see, triple bond, there you go.
Can I
You got that
see
triple
it?
bond going on.
I thought this
Okay.
was been 3 times.
I thought this were
Instead
been
of
where?
the triple
Wait,
bond.
Okay,
Destiny.
so-
Face yours?
Do you guys see how the
Well, I got the
bonds
triple
help
bond
you
like this.
visually
Oh,
visualize what you're actually drawing, right? And you see how much it looks like that skeletal structure. Okay, so let's add another layer. You guys ready for the next layer?
No.
What?
Oh, no, sorry.
Don't worry about it, you'll make some more models. You guys make some more models.
Oh, are they good?
Yeah.
Okay,
Yeah, the triple bond is missing.
Well, yeah, I know where it came from. I just thought the
so
one of them were.
there was a question. The question was, what happens if there are two triple bonds? What happens if there are two triple bonds?
Well, then you put it
The
on.
question was, what happens if, you guys already know, so, I'll stop. Stop right now. Don't worry about it. It'll be on your test. Don't worry about it, Okay, you guys ready?
Yeah.
Okay, good. So, what happens if there are two triple bonds? How does that change the name? So, let's put two triple bonds here. Okay, so again, we're gonna try to decide where to count, right? So we have to make a decision. Which side are we gonna start counting from? So you're gonna go with the one that gives you the lowest numbers, right? Okay, so here we have 1, 2, 3, 4. If we go the other way, we go 1, 2, and we're on the second card. So 1 is more than 2, so we're gonna start counting from this direction. Okay, so we have two triple bonds, right? So when we have two triple bonds, we have to use another set of prefixes, right? We have di, we have tri, we have tetra, and then everything else stays the same after that is penta, hexa, hepta. Octa, nona, deca, dodeca. Oops, sorry, undeca. Undeca. Okay. So now we don't want to mistake the prefixes for the number of carbons for this, although the ones down here are exactly the same, the first ones are different. Okay, so pay attention to that. Okay, so then we would call this guy, it's how many carbons?
5.
5 carbons.
Yeah.
So we have 5 carbons. So 5 carbons are what? 10. Okay. So we're going to say 10th, and then we say how many triple bonds there are. How many?
2.
There's 2, so then we use prefix for 2.
Die.
Penta, di, I.
Y and
Okay, so we have to say where they're located at. So we put that in front. So it's at the 1 carbon, and it's also at the 3 carbon. So we call it 1, 3 pentadiene. Diene. Okay. So this is one way of writing. There's another way of writing. And this one is kind of better in a way because you put it right where it belongs. Penta 1, 3 diene. Okay. So those are your two ways of writing. Okay, the second one, although it looks ugly as hell, it is still ugly, right? But it's easier because you're putting it right next to what you're talking about. So that tells me I have 2 triple bonds. Okay, are you guys with me?
Yeah.
Let's see if we can make it hard, right? You guys ready for it to be hard?
That's messed up.
Can you handle it?
I don't know.
Okay.
Perhaps.
We're gonna go ahead and raise this part right here, we get a little more room, so right? Yeah, guys, room to down.
So if you're counting to wherever you get the first, and one for the second, you have to count from that side.
That's right.
Okay. So you don't do it.
No, you don't, once you made the decision how you count, you just stay that way. Okay. So let's start counting. First thing that we want to do is count the carbons. Okay, which side are we going to start counting? The left. 1, 2, 3, 4, 5, 6, 8, 9. Okay, so it's a 9-chain carbon. 9-chain carbon. So what is a 9-chain carbon? Okay, so it's no now, or no. Okay. Then what are we gonna do? Was it a die? So no, die. We put that A in to kind of they know that die. The triple bond. So how do I say triple bond? Die. Know that die. And then what do I also need to do? How many? We already got how many there were?
Where it's at,
What's that?
where it's at 2 and 4.
2 and 4. So it's 4. Right. Or we could have wrote it like this. Nona 2, 4. Okay. Okay. Okay, we counted the carbons. 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? You want to count? You want to count from the side that gives you the question. This here's a triple bond, right? So triple bonds is going to end with Y and E. Double bond is going to end with E. Right? A single bond is going to end with A. Okay. So then it has 9 carbons. 9 carbons. So right. Put it to kind of like and then we put how many triple bonds we have, which is 2, right? That's the die. 2, okay, and then triple bond. Okay. So the last thing, so there's like a hierarchy, right? So you know, kind of like I'm poor, right? There's a rich kid, there's a really rich kid. That's a hierarchy, a class system. You guys are familiar with the class system, right? Because we live in a class system. Okay? So the last name goes to the one who's the most important, the one who has the most money, right? So it's kind of like we're in a patriarchal system. So the woman takes the man's last name, right? So the triple bond is more important than the single bond. Okay, so it ends up with its last name. Even though there are single bonds there, we can clearly see that there are single bonds here. The triple bond is the one that's most important, so it gets the last name. So the last name always ends with the triple bond. Okay. Okay, you guys got it. See how that works? Okay, so you guys wanna test it out. We're gonna try one more and then we're gonna move forward. Okay? Did you guys get that down? After I listen. Okay. So, you- don't worry about it. I'm glad I'm doing it work. It's just sitting on. Okay, so where am I gonna start counting from? Actually, it works out to be the
Either way,
same
yeah.
either way I go, right? So I can start from either way. Okay, so that's right here.
Right.
1, that's 2, that's 3, that's 4, that's 5, that's 6, that's 7, that's 8. So you always want to count the longest carbon chain. I'm gonna add a whole nother layer. Okay. 8. Oct. Okay. Octa,
Off the try.
tri,
E.
ene. So it'll be 2, 4, 2, 4, 6, octatriad.
That was easy.
Escape.
How many bonds are there? Or how many double bonds?
Okay, you got it? You see
The
it?
others were confusing. That was
You guys are good?
Yeah.
Yeah.
Okay,
What is
good.
this?
So let's add a whole new layer.
What the heck?
Whole new layer, right? Because this is too easy.
I'm running my house just use the first layer.
Okay, what happens if I have a double bond and a triple bond?
Oh, my goodness.
Oh, oh my gosh, right? No, it's not two different names, it's one name, right? This is one compound. So let's talk about if we have a double bond or triple bond. So double bond and triple bonds are considered to be equal, but not equal, right? So they're supposed to be equal, but not equal. So let me explain to you what I mean by that, right? So the double bonds are more frequent or common, so they're more important, right? The triple bonds are less frequent, less common. They're less important. It's just a little bit less than each other. So you want to end with the double bond, not the triple bond. Okay, so the double bond would have the last name. Okay, but when you do the counting, you have to count for either the double bond or the triple one, whichever gives you the lowest number. Okay, so and I don't know why they did that. They're like, hey, we're gonna give it the double bond's last name, but it just depends on where it's located, right? It's really done, right? They're not consistent enough, which is unfortunate. You do it anyway, right? Because that's what you do. So let me give you an example. So, everybody got this one?
Yes.
So let's say we have this structure, and then we have double bonds. Okay? So we're gonna start counting the one that gives us the lowest number with either a double bond or a triple. Okay, that's where we're gonna start counting. But we're gonna end with the double bond's last name. It's gonna end with E, right? Okay, so let's start counting. So am I gonna be counting from the left or am I gonna be counting from the right? On the right. So we're gonna use the blue count. 4, 5, 7, 8, 9. Okay, so we're using the blue numbers, not the red numbers. Okay, so way that we would do this, we have to say we have a triple bond, but we don't want it to end with an E. So the way that we write the triple bond, not ending with an E, we put Y. We don't put the E. Okay. If we had a double bond and we didn't want to use the last name, you put E. And that would signify the double bond. And you guys already know the AN means. Okay, so this guy is 9 carbons. So 9 carbon is
No, or no.
known. Okay, so how many triple bonds do we have? So how would I signify 2? Di. And then YN. And then di.
Yeah.
Okay. And then we put EN, right? Because that's going to be the last thing. Okay, so we're going to shift this around a little bit because now we have to say where they're located, right? Where is the,
So 6,
The-
8,
it's located, remember,
oh, 1,
lowest number, 1, right? So it's 1
and 3.
and 3. Okay? The triple bonds, look at the blues, 5 and
7.
5 and 7. Nona, 5, 7, di E, 1, 3, di E. So di I.
Why'd you go the other way? The numbers.
Because double bond started at 1.
So,
Triple bond starts at 2.
oh, okay.
You always want to give it the
Right.
lowest number.
I have a question. So
Yes,
when you're coming from left to right, it goes on the bottom. So like the number on the bottom. You get how it is 1, 2, 3, 4, 5, 6, 7, 8 on the top.
So here, so
Yeah, on the red
if I
ones.
go this way, it's
Yeah.
1, 2, 3, 4, because you're counting
it's the
every
opposite.
carbon.
It's the opposite direction. It's something on top. Like how you know how the red ones are on top.
Yeah, it doesn't matter where you put the numbers, you just want to count the carbons. You can have them alternate if you want.
Oh.
Whatever point you go,
They're probably just carbon.
as long as you make sure you count it right.
Oh.
Yes.
What?
You start off, the first part of it tells me the carbon chain, right? That's gonna tell me the first one.
Okay, and after that.
And then you tell me where are the special things located, right? No. So you always want to end with the EN, because ENE technically is a little more important than YN, right? So you always want to end, when you have both, you want to end with the N. But when you do the counting, right? So other structures, it's going to be, you're going to start counting to give that structure the lowest number possible. But for all of your hydrocarbons, technically, they're all even, technically. So you want to try to give whatever one has the lowest number, the most important. Okay, so in this case, E and E was lower in numbers, so we started counting on this side. Okay, try to give you the lowest number possible. Okay. You guys are clear on that? I know, not really? Okay, so.
That's really only with double and triple bond.
Exactly.
Double bond, it was-
That's right. So when you're looking at double and triple bond, right? So you want to just get the lowest number possible, right? If you're looking at double and triple bond, you want to get the lowest number possible. So clearly, 1 is lower than 2. Right? So because it's clearly lower than 2, so that means that we're going to start counting from this side rather than start counting using the red. Okay, so we're using the blue to count, because we want to get the lowest number possible, period. So when you're working with things that are just hydrocarbons, the lowest number possible. Okay? Now, in terms of priority, who gets the last name? Because the last name is the most important. Like, if I get married, my wife is getting my last name because I'm the most important. She just doesn't know that yet, but she's got to learn, right? So, the one that gets the last name is the most important, right? So you end with the E-N-E because it's more important. It's a little bit more important than the Y. And the reason why it's more important is because it's more frequent than the Y. Okay, so, yeah.
Oh, my God.
Okay. Okay, no, because we're gonna add layers, right? Okay, so if we look at this, right? A and E is at the bottom of the totem pole, right? Then we have E and E. That's showing up over there. Okay, I mean, sorry, not E and E, Y and E. And then E and E. E and E, Y and E, A and E. Okay, so in terms of importance, A and E is bottom of the totem pole right now. Then we have Y and E, that's the second bottom. Then E and E, that is the least. I mean, that's the most important.
Where we are.
Get myself confused. Most important, least important. Least, most. Okay, you guys got that? Okay, now we're gonna keep this here because we're gonna add stuff onto it.
41.
Oh, we got plenty of time. I got 2 hours, right? Okay. So you guys ready for the next one? Ready for the next layer? Get past the next one. Okay, so we can have carbons branching off of the main chain. So when you have carbons branching off the main chain, we have to take into account those carbons. Okay? The first thing that you want to do is find the longest chain. The longest chain. So we're going to count the longest carbon chain that we have. That's 1, that's 2, that's 3, that's 4, that's 5. 5 carbon chain. Now, the branches, we want to give them the lowest number that we could possibly give them. Now, if we look at the branch, this is 1 carbon coming off of it. So what I'm going to do is write 1 in a circle. Let me know that that's only a single carbon that's coming off. So this one is also only 1 carbon that's coming off. Okay, so I'm going to write 1 carbon in a circle. So that lets me know that that's a single carbon coming off of it. If it's a single carbon, what would be the prefix that we use for a single carbon? Net. Okay, so this guy we call is a 5 carbon chain, which is the main chain. Okay. And then they're all single bonds. Okay, so that takes care of that main chain. Now we have to take care of these side chains. Now, when it's a side chain, we put the prefix what it is. It's a single carbon. So then we put meth, and then we put YL. So that lets me know that it's a side chain. So YL means a side chain. Okay. So this guy, it's methyl, right? So that's a methyl. This is a methyl. Now, since I have 2 methyls, I don't want to write methyl. I'm going to call it dimethyl.
Oh.
So dimethyl. And I have to tell you where it's located. Where is it located? On the main chain. 2, 3 dimethyl pentane. Okay. Okay. Yeah. Get it? Little bit.
Yeah.
Okay. Let's see. Let's see. We're gonna add one up here. We're not gonna add a layer yet. We're gonna get to the
I get.
Okay.
Oh, it's actually.
That's just ice on there, right?
You're just launched it. And you just have to make it.
The funny thing is that there are a couple of things that are like, yeah, I'll do yes, and you'll come. Yeah.
Okay, I got it. Give us 5 minutes.
I'll give you a little bit of time.
But ice,
Give us 5 minutes.
I'm telling you, you did it on rocks. Yeah.
One, two, oh, now there's double bond. What's the next part?
Well, it's not the double bond, it's just double bond. It's just wanna treat it like you treated before, right? It's a double bond. It's not gonna be different.
No. I don't know if I put one on, or if it's like all one at the end. Oh, I think you just- So we're supposed to do the same?
I did it.
I guess, and I feel apply this whole semester dedicated to organic chemistry, right?
Try.
Like on the side change or on the side?
That's what I was thinking.
For it being all one.
Because it goes on to 6, huh?
My side kick, get my side piece, and a side kick.
I think it's a really good enough space.
You guys ready?
What? You think enough see money?
I think that the end tail's throwing me off.
I think it's.
Don't be too comfortable. Don't, I wouldn't.
That's what I wrote. I wrote.
Get started. Okay, ready?
Yeah, I probably got it wrong.
Okay, am I gonna start counting from the left, or am I gonna start counting
From the
Left.
Are you sure?
It can go either way, can't it? Because
It
it's
it
a
can actually go either way, right? So, it can go either way, but we want to incorporate the most with the lowest number possible, okay? I know, here we go. Right? Now, when we call side chains are gonna be valuable as well, right? So we want to give them the lowest number possible because they're all hydrocarbons. So the double bond, we want to give a low number, but if the side chain has a lower number, then that's fine. Okay. So start counting. 1, 2, 3, 4, 5, 6, 7. There's 2 structures here. There's 1 structure here.
Yeah.
So this would give us our lowest number, right? Because it'll be 2. Over here we'd have 2, then there'll be something at 3. Here we'd have something at 2, 2, and a 3. Okay. So help me out here. Our longest chain is 7. You can just count it. How many carbons are coming off of the second carbon? There's 2, but they're independent of each other, right? So each one is 1. So we're going to put 1 in the circle here, 1 in the circle here. Okay. Now this one, how many carbons are coming off of it? 1. 1. So we're going to put 1 in the circle here, 1 in the circle. Okay. You guys see that?
Yeah.
Single carbon. So if it's single carbon, it's called what? Meth.
Oh, I get it now.
Okay. Now with the side chain, so we put YL. How many of them do we have total?
4, so it's 3.
1, 2, 3, 4. 4, so it would be
2.
tetra. So it would be tetra, ethyl, and we have to say where they're located. So we have 2, so it'll be 2, comma 2. Let's tell where both of them are located at. Then we have 1 at 3 and 1 at 6. So it's 2, 2, 3, 6, tetramethyl, and then M. Heptene, because there's a double bond. Where's that double bond located at? At 4. So it's 2, 2, 3, 6, tetramethyl, 4 heptene.
So I got it right.
That's those numbers, right?
Yeah.
Wait, there's a little one.
Okay, so let's do this. Okay, so let's count the number of carbons. So we want the longest chain. Now this is a ring structure, so they're going to go together, right? Since it's a ring structure. So you're going to start counting from the one that has a side chain that is the longest. That would make the most sense, right? So 1, that's 2, that's 3, that's 4, that's 5, that's 6, that's 7, that's 8. Since it's a ring structure, I need to put 1 in front of it. Cyclo. Cyclo. And 8 carbon. Oct. All single bonds.
No.
Cyclooctane. Right? So it has a side chain. On the side, it has, on the first carbon, it's 1, 2, 3, 4. So if it's a 4 carbon chain,
Oh, no.
yeah, but it's going to be bute. So it's going to be butyl. Butyl, right? So we need 1 butyl. Okay. On the third carbon, that's 1, that's 2. Okay. So there's 2, 1, 2 off of it. So there's 2. Because it's 4 carbons. This is, let me renumber this. That's 1, that's 2, that's 3, that's 4. Right? 4 carbon. Okay. This one has 2.
Are we?
1, 2. So. Okay, so ethyl. So on the third one. So, and then we'll put it all together. So ethyl, and then on the fourth one. Ethyl. Okay, so. Okay, so the way that you do this now, right? This guy, the cycle octane, that's going to be at the end. Now, these guys are going to be done alphabetically. B comes before E, which comes before M. So then you're going to put the B first. So then your name is going to be 1 butyl 3 ethyl 4 methyl 5-flow octane. Okay. Okay. Let me see if I can do it so you guys can actually see it.
Yeah, that's one. What about the first one?
Okay.
I also have a top one on 4, the one that's sticking out on 4, so I thought that one was meant to. Oh, why is there a 4 in front of it?
Okay, you guys see that?
Oh,
Yeah.
okay. I see it now.
Okay. Are you feeling comfortable? Almost?
Again, most of it. Just more layers.
I think I understand.
No more mirrors.
Remember?
Yeah, so if you have
No more time
options,
for other
options
layers.
like the
No
three,
more
you
time.
can make any one of them, right? So you want to start with the one that's the longest side. Crazy.
Yeah, but is it 4 methyl?
We're starting
Okay.
out.
It's methyl?
One, you said.
It's like.
When you're putting, yeah, we have multiple of them, so for instance, we have butyl, ethyl, and methyl, right? So then these guys are gonna go out together. So the sub and front will be out together.
I know, but
Okay. So you guys ready? We're gonna add a whole nother layer. You guys ready?
Good, we got 2 minutes of class.
Oh, don't worry about it. We're gonna earn earn this 2 minutes.
Oh, yeah.
Earn it, right? Okay, you guys ready? Okay, so you guys have been introduced to slide chain. So we also have things called substitutes. Substitutes is where we basically substitute a chemical, another chemical for the carbons, right? So it's no longer just a hydrocarbon, it's a hydrocarbon with something else added onto it, right? So let me give you an example. What is F? Fluorine. Okay, so here we added fluorine to this hydrocarbon instead of having hydrogens, right? So when we do this, this makes this guy called, it's called a an alkyl halide. Okay, it's called an alkyl halide. So remember alkane, right? Alkane, alkene, alkyne, right? That's what it is. So it means it's a hydrocarbon and it's a halogen. Okay, so anytime that you have hydrocarbon and a halogen, what you're going to do is you're going to count the longest carbon chain again, right? So 1, 2, 3, 4. Now, here, you're going to give it the lowest number possible, right? On any of the side chains. You're just going to try to get whatever side chain the lowest number possible. Okay? It doesn't matter. Now, the halogens have a lower priority than your alkanes. So they fall below them. That's the reason why I wrote it down here. So further. So they're lower in priority. Because they're lower in priority, we always put them in front, right? They're always going to be a prefix. So this guy is fluorine, so we would call it fluoro. Fluoro, right? So there's two of them on the second carbon. So what do you think I'm going to do with that? Di, so it'll be difluoro, and then I have to tell you where they're located. Okay, so it'll be 2, 2, 2, comma, 2. It's chlorine, and then we put an O because it's a prefix. So all of your halogens, they're going to get an O at the end. Fluorine is going to be fluoro. Iodine is going to be iodine, right? Bromine is going to be bromo. Bromo, okay? And then we have 1, 2, 3, 4. 4-chain carbon. 4-chain carbon. Butane. Okay, so this guy would be called 2, 2 difluorobutane.
So there will only be
It could be anything, but right now it's only halogens. You haven't learned anything else.
So
Hold your horse. We'll get there. Okay.
halogens end with an O. You add an O to the end of it.
Yes,
for
so the halogens, you add an O. So you just truncate it, you get rid of the I and E, you put an O. So like chlorine, it's going to be fluoro. Okay, so chlorine, right? It's going to be fluoro. Okay. If I had astatine, it's going to be okay.
Hey, you sound the O.
Is it aqua or equal? Equal highlight? The under the A. On the side, on the side.
I have to look at it.
What does that mean? That's equal.
Okay,
What does the equal halide mean?
achial,
Yeah.
achial. So remember, these guys were called, if it was single bond, they were called alkanes.
Oh, so it's like when you add a halogen and you add
Alkanes.
the,
So
the hydrogen
achial,
carbon.
and then we had alkenes,
So like,
right? So that first part, alkyl, right?
Yeah.
Alkyl, that basically means a hydrocarbon, right? So this means hydrocarbon. And this means halogen.
Okay.
so it's when you add those two together in the same.
Okay, so you're telling me it's a hydrocarbon that has halogens on it.
Okay.
Okay? Good, good. You feeling it?
Yeah.
Okay. So on Monday, we will be talking about alcohols. We'll be talking about ethers, and we'll be talking about esters.
During the substitution.